In example 6, we need to use the following functions to evaluate a, b, and c. There's a couple different ways to do this. Let me give you one method, and that's to take 5 and substitute it in the appropriate function. So we'll have negative 5 times 5 minus 3. Here's the plus sign. F at 2 is going to be 2 times 2 plus 6. You could also do g at 5 first, figure out what that value is, find f at 2, figure out what that value is, and then just add them together. Here we can just do order of operations though. 5 minus 3 is 2. 2 times 2 would be 4. So we've got negative 10 plus 10, which is 0. So when we add these two functions that are evaluated at 5 and 2, respectively, we get 0. H of 8, let's try this. So h of 8 is going to be this function. It's going to be 1/2 times 8 plus 4. And when there's a minus sign here, you definitely need to use your parentheses. So now we're going to do g at 3. That's negative 5. 3 minus 3. Remember, 3 here goes in for the x. 1/2 of 8 is 4. Negative 5, then 3 minus 3 is 0. 4 and 4 is 8. And then we're going to have minus negative 5 times 0, which is 0. So we're just left with 8. This will totally matter, though, if this number is something other than 0, because we're going to need to do the opposite of that number. This one's a little tricky. First, we want to figure out what g at 4 is. So let's see if we can figure that out. That's a negative 5 times x, which is 4, minus 3. So we got 4 minus 3 is 1, and that's negative 5. And now what we want to do is we want to take f and evaluate it at what g of 4 is. So that's negative 5. So it's kind of like this is called a composition of functions. It's sort of a double problem if you ask me. Kind of nifty trick. And then we've got 2 here times negative 5 plus 6. That's negative 10 plus 6. So we have f of negative 5 being negative 4. So first figure out the inside part. G of 4 is negative 5. Then take f and evaluate it at negative 5 and you get negative 4.